Hi, welcome back. So we're in chapter 5, reduction by probability, at the outline of introduction to probability. Let's go ahead and explore some extra information that we need to be familiar with. We have actually explored the relation between probability and random in the very first introduction. And now we're going to look at something called random experiment. What does that mean actually? A random experiment is a kind of a process by which we observe something uncertain. The experiment itself of taking the measurement. So when you do your measurement, then you will get the result. But the point is, what happens before taking the measurement? We were in the kind of world of uncertainty. So the transformation from this uncertainty to specific outcome from this experiment, this particular space between them we call the sample space. The sample space, usually it's related to the type of variable that we are dealing with. I can focus on some particular vocabulary maybe you need to be familiar with. It's called the outcome, and the outcome means the result of that random experience, which is in here. Also, maybe you can look at something called the sample space, which is the set of all possible outcome could happen from that particular experiment. For example, if I flip the coin one time, all the possible sample space could be head and tail. This is the universal set. Could look at the word event. It's a subset of the sample space. This, don't forget, it is a subset of this. So if this is an A and this is an B, it's basically to say that B, it's actually a subset of the A. Quick example can help us. Let me take it from a discrete perspective of X, flipping a coin 3 times. So what is the sample space when we flip it 3 times? Well, in the first, I get head. In the second, I get again head. In the third, I get again head. You could see this pair represent the outcome of 3 flipping of the coin experiment. This is one possible outcome. Well, these are the all possible way of combination outcome could have happened. I get 2 possible outcome, and I've done that 3 times. So it's as simple as raising that power of 3, which is going to be 8 possible outcome. One important thing you have to know that the total of all the probability, it must sum to 1. This got 1 out of 8. This got 1 out of 8. If you sum all these 1 out of 8 times, you will get exactly 1. Let's say, for example, election, and you got 3 candidates. Okay, let's call them candidate A, candidate B, and candidate C. Can A have a chance of 20% to win? Candidate B have 40%? So if you ask what is the probability A or B could win the elections, language of set theory, well, A, uni B. One thing I know for sure, that both of them cannot win at the same time. A intersect B, it's absolutely is equal to 0. 20%, 40% probability of this or this to win, it's 60%. But the actual fact that should be minus the intersect between them, which is going to be 0 here. Let's call this event, the ring of today, it is A event. Ring of tomorrow, it's a B event. We have learned about the complement rule of set theory. So the probability A not to happen and B not to happen equal 0.3. These are the information are given to us. Let's say the first question says, what's the probability it will rain today or tomorrow? First of all, let's translate this into a set theory as we understand it. The event of A or B. We can use the complement. So the unit between them, it's 1 minus the probability unit between them, but not to happen. Can we simplify this? A unit B complement, it's exactly equal to A complement intersect with a B complement. And just now we have proven that this form of A unit B, probability of not A to happen intersect with the probability not B to happen, 30%. That means the probability of this is 1 minus 0.3 is equal 0.7. Okay, how about what is the probability that it will rain today and tomorrow? It's exactly as writing the probability of A plus the probability of B minus the intersect between them. If you sum that up, it will come to 0.4. Some extra information that we have to be familiar with, and that's something related to what's so-called conditional probability. is about if you obtain an additional information, how you should update the probability of an event. Imagine if I would have told you that the probability of rain in certain region is like, say, 20%, for example, on any given day. So in this case, if I would have asked you the third day of the week, you would say, well, it's 20%. But suppose that I pick that random day and I also tell you that it is cloudy on that chosen day. Now you are giving an extra information how you're actually going to be exactly integrating that probability of this event. We call it R. The event is C. So what I'm saying is probability of rain, given that this is the conditional symbol, given that it is a cloudy, actual formula, if we are given two event A and B, equal to the probability of A intersect with B divided by the probability of B. Logic to think that the probability of B actually should be larger than 0 because we don't want to divide by 0 anyway. Now, let's look at this example. We roll die 2 times. This pair here to represent a possible outcome. If I would create my knowledge of matrix, I can get 1 and 1, 1 and 2, and so on. You will get 36 possible outcomes. Other way to think about a problem from mathematical perspective, well, I know the outcome are 6. Well, if I raise this power of 2, since it's twice, I will get actually the value of 36 possible combination out of that. The sum of x1 plus x2 for assumption is equal to 7. So for example, 3 and 4. What is the probability at any given possible pair? X1 should be equal 4 and x2 should be equal 4. In other words, pair should be the sum of them is 7. X1 is 4 and the other could be any value here, or this could be any value, the first row, and the second one is 4. What's the probability of this event to occur? Let's translate this to a conditional probability. So let's say this is event A, which is x1 could be 4 or x2 can be 4. This is the first event. Event B is this one, that the total sum of these pair is equal to 7. Now, what we want to find actually, what is the probability of A given that probability B has occurred? Following what we said just now, it is the probability of A intersect with B divided by the probability of B. That's what we know so far. Now, if I want to do a manual way, by defining the possible A event, that could be is the following. Well, I could have 4 and 1, could have 4 and 2. So you pick every 4 possible in a pair and just put it down here. Then you'll get all the space of the A. What is the space of the B? Should be the pair that the sum of them should be equal to 7. Well, so you get like 6 and 1, 5 and 2, 4 and 3, 3 and 4, 2, 5, 1, 6, etc. Anyway, that we can find A intersect with B. 2 pair will be actually here intersecting with each other. That is 4, 3, and 3 and 4. 2 over 36, 36 the total, divided by the probability of B. It's going to be 6 over 36. Well, these terms are gone, 1/3. Now, the next thing maybe we want also to be familiar with something related to concept of independency. What does independency mean? Event A, tomorrow is gonna rain. There is another event tossing a coin, for example. Probability of B here. What's the probability of A given B? What's the probability of B a rainy day given that I toss the coin? I would say, well, it is 1/3 because given the fact that I toss the coin, it will not affect actually the condition of the weather. In this case, both event A and B is called to be independent. Outcome of one, it doesn't affect the outcome of the other. The intersection between two events, if they are independent, is equal to probability of A multiplied by the probability of B. If you want to reconcile this definition with what we have mentioned earlier here, let me give you an example. Let's call this random number n. So A says n is less than 7 and B says n is an even number. A and B, are they dependent or independent? A in this case is equal to 1, 2, 3, 4, 5, and 6. And let's define B, 2, 4, 6, 8, and 10. Well, the probability of A is 60%. What is the probability of B? 50%. Now, what is the probability of A intersecting B? 0.3. You got 2, 4, and 6. Now, the fact is that this number is exactly equal as if you multiply the probability of A, which is 0.6, by 0.5. that means both events are actually independent. Now, before I leave the independency part here, many people have a problem to actually visualize the fact that independency is different from disjoint. You got two events like A and B. These are disjoint. Why disjoint? Because they have the intersections be equal to 0. It's completely different. You might have this A and B, okay, intersecting with each other, but A is independent from B. So the outcome of A has nothing to do with the outcome of B. So this image, when people hear the word of independency, they might visualize this image of disjoining, which is not true. Now, the next thing maybe we want to talk about is something called the law of total probability. Now, what does that mean? Let me actually give you an example. It's easy to explain. Imagine in this first bag, we got red and blue marbles. It's 75 red marbles and 25 blue. In the second one, 60 red and 40 blue. And the third one, we got 45 red and we got 55 blue. Say I choose one of the bags at random and then I pick a marble also at random. What is the probability that the chosen marble happens to be a red color? Let's assume R here to be the event of choosing a red marble. B of I, any of these I can be 1, 2, or 3, event that I choose bag I. So we get this probability of choosing a red marble, but giving a condition of being B1 or B2 or B3. Now the question is, what is the probability of R? Now what I know about R, getting a probability of something using the word of and the word of or. Now when we say and, we indicate multiplication. When we say or, we indicate addition. As if I am saying it is the probability of R, given that is a bag 1, multiply should be by the probability of B1. Why? Because it is and bag 1. But we have some other also probability could have happened here or here or here. So you got 60% chance of picking a red marble from this complete random experiment. Okay, so we can continue also what does sampling mean. Is to form set, choosing an element from that set. In other words, draw a sample at random from a given set. We will talk about sampling from sets for possibilities. Okay, I'm going to write them down here in bullets. Order sampling with replacement, ordered sampling without replacement, unordered sampling with replacement, and then finally unordered sampling without replacement. Let's just start first of all with ordered sampling with replacement. Let me give you an example straightforward. Imagine I got a set of A and then say I would like to choose 2 numbers. So you get K is equal to 2. What does it mean ordered sampling with replacement? First of all, ordered sampling means the order is important. That 1 and 2 is different from 2 and 1. With the replacement, that means 1 and 1, it's possible. So this matrix, it's all on from upper diagonal, lower diagonal, under diagonal. To conclude, the actual formula of order sampling with replacement, it means all possible combination of this particular matrix will be n to the power of k. Let's go ahead and discuss now the second one, ordered sampling without replacement. Ordered sampling means 1 and 2 is different from 2 and 1. Without replacement, what does that mean? So that means all the diagonal have to be off in this matrix. Let's move on to the next one, unordered sampling without replacement. So unordered sampling, what does that mean? 1 and 2 and 2 and 1 are exactly the same. So we count them as 1. The upper side of the diagonal, it's off. Without replacement, what does it mean? This is what we call the combination problem, which is from n, you are choosing k, which is actually the formula of n factorial divided by n minus k factorial multiplied by the k factorial. Now, the last possibility, unordered sampling with replacement. Unordered, 1 and 2, is exactly 2 and 1. But with replacement, diagonal will be on. So I think that's all what we have got to really understand and be ready to move and try to actually explore now our map. That's exactly what we're going to do next. I will see you then.